Hello, and welcome to this edition of Math Teacher to Go. Today's lesson we're going to discuss interval notation, how to read it and how to write it. Interval notation is a way to express a set of values that's more than just single numbers that would be a continuous set of numbers like, well, right here we have -2 less than x less than or equal to 5. You know how to write that. We call that inequality notation. But we'd like to express that in a simpler way just using a pair of numbers. And we use different types of parentheses to indicate whether or not there's an equal sign or not an equal sign. So we have here in -2 less than x less than or equal to 5. The -2 is not included. The 5 is included. We will indicate that the -2 is not included by putting a rounded parenthesis on the left side. Then we will write the -2, then we'll put a comma, and we'll put the 5, and then we'll put a square bracket. This may be the first place in mathematics where the shape of the grouping symbols have mattered. Sometimes you use brackets in algebra so you can see which pairs of things go together. But in this case, it's actually going to have a specific meaning. It means that end would be included. Any end that's adjacent to a square bracket means that point is included. Now, that's an interval between 2 points. And you say, well, what about x greater than 5? There's only 1 point. Well, that really is between 2 points, as we're going to see. That's between all my numbers between 5 and infinity are good. The 5 is not included because there's no equal side, and the infinity is never included. So we'll have round parentheses on both sides of that interval. And x less than or equal to 3 is similar to that, but it's all the numbers less than 3, which means from negative infinity up to 3, and it includes the 3. So for the -2 to 5, we see we have the parentheses, the 5 with the square bracket. That means the -2 is not included. The -2 is the left. It always goes left, comma, right when you write these. I'm trying some new technology, so pardon my poor handwriting. But the two numbers are always left, comma, right. 5 is the left end of the x greater than 5. Infinity is the right. If you think of a number line, if you have your 5 here and your infinity here, that you were including all of these things in between. And in that case, you were not including the 5, which when we did inequalities, you would have written with an open circle. The equivalent of an open circle is we put this rounded parentheses next to the 5. And if you were told on the interval 5 to infinity, it would be written like this for shorthand. -infinity to 3 for the x less than or equal to 3. Now notice for the 3 we have this square bracket. That's because the equal sign is there, the 3 is included. That one would be a little different, but similarly we will look at our number line to tell us what to do. There's our number line. I have to learn to draw straight, sorry. And here's our 3. That 3 is an important number. Now if I was graphing this in a number line, which is the visual representation of this inequality notation, I would put a closed-in circle and I would go all the way to the left. Well, at the left is negative infinity. So you can see the left end of my interval is negative infinity. The right end is 3. There's the left, comma, right. Every time you use interval notation, that's what's inside. The left end point, comma, the right end point. Whether you use a round parenthesis or a square bracket is determined by whether that end point is included. Here, negative infinity, you can never get there, so it's never included. Any form of infinity will always have a round parenthesis adjacent to it. The 3 is included, so it has a square bracket next to it. So that's the basics of interval notation. Now we're going to look at some more some more ideas and more examples as we go through. So you should be familiar with this inequality notation. That's all that is saying. X less than n. Just this says x is less than n when n is some number. So if I had some number n on the number line, there's n, Now the n is not included. There's no equal sign there. So it would go like this. And if you look at the interval we're talking about, the left end is negative infinity, and the right end is whatever my number was, in this case, n. So the way we would write this in interval notation, the negative infinity is never included, so that's a nice round parenthesis. Negative infinity, the left end, comma, the right end is whatever my number is for n, and that also is not included because there's no equal sign, so I would have what almost looks like a point. That's the only confusing thing when you have neither end of the interval is actually included in the solutions or included in the inequality. It looks like a point. It's just surrounded by parentheses. But within the context of the problem, you would be told on the interval, and then you would see this symbol, and then it would make more sense. You would say, oh, that's not a point, especially when there's infinities in it. You would recognize it gets more confusing when they're two numbers. So similarly, x is greater than n. So if this is my number n, remember we would use an open circle, and we would go in that direction. And you can see now n is on the left end of the interval, and the right end is infinity. So I do not have the left included, so that's an n, comma, infinity. Infinity is never included, so both round parentheses because there's no equal sign in my inequality. So this one is similar to the first one. Look, the first one was x less than n. This is x less than or equal to n. Oh, in this case, I've already got my n typed in there, so I'll pretend that's where n is. Now, here's the difference. In the number line, I would have made that a closed circle. When I learned to graph these inequalities, I learned that the closed circle meant n can be one of my answers, or n is part of what I'm talking about. And I go, again, less than would be to the left of. On the number line, left is always less than to the right. I have the left end is negative infinity. The right end is n. So every time I write interval notation, I write whatever's on the left end, comma, whatever value's on the right end. In this case, that's an n. And then I can decide what symbols I put on with each. Now, next to the negative infinity is never included, so that's a nice round parenthesis. The n in this case is included because of this equal sign, so I use a square bracket. So this tells me I start at negative infinity and go up to and include n. Those are all my possibilities for this inequality. And this usually results as you've solved some inequality expression to isolate the variable, and this is your solution set. So similarly, x greater than or equal to n, this time n, so you would fill in the circle when you used to graph this. And the reason I'm graphing this is to get started on interval notation, you might find it easier to draw this graph first and then decide what's the left and what's the right and how to use the parentheses or the square brackets. I can see in this case n is on the left, so it's n, comma, infinity. Don't switch that. The first number is always the number on the left if you had graphed it. Now the n is included, so I get a nice square bracket adjacent to that, and infinity can never be included, so I get a round parenthesis there. These four examples we just did, where there's only one number involved, tend to be more difficult for students. We started with those as examples. In the next example, we're going to have our values are between two numbers. We have two concrete endpoints that we actually understand a little better than infinity. So what if I came up with a solution that said my x is between and n is less than x, which is less than or equal to m. This really just means x is between n and m, but can't be n but could be equal to m. So in this case, I need two numbers to show this. N is the one on the left is m because that's the smallest. The inequality signs always point to the smaller values. They always point to the numbers on the left. So, and let's say this was my number m. So the n is not included, the m is included. So I got an open circle on the n and a closed circle on the m, and my solutions are in between those. Now, if I look for where my solutions are, that bar I just drew, the left end is n, the right end is m. So it's always left comma right. So I'm going to write n comma m. The m is included because of the equal sign and the n is not. So I have a round parenthesis next to the n. See, that open circle corresponds to a round parenthesis. Okay, so that's when our solutions are between two numbers. Now, if there had been an equal sign here, this would also have been a square bracket. So interval notation is just another way of expressing what numbers are allowed in a solution. I have a little issue here. There we go. Okay, so the smallest value x can be is always written on the left. Then there's a comma. Then the largest is written on the right. If the left or right end is included, in other words, has an equal with it, that side would have a closed circle in the graph, and the end is enclosed with a square bracket. If the left or right end is not included, or if it's infinity or negative infinity are never included. So if you had negative infinity on the left, it would always be a round bracket. If you had an interval where positive infinity was the right, it would always be a round bracket. So let's try some examples with things besides ends. Let's use some numbers. So we want to write x is less than negative 3 using interval notation. So if I were a student learning this, I would probably find it easier to draw the number line first, because then I can look and see the left end and the right end. So I just draw a number line and I put a negative 3 on it somewhere. Now, less than negative 3 is an open circle, and less than means to the left. So you point to what's on the left with the inequality symbol, saying the x's are on the left of negative, or to the left of negative 3. So you're highlighting everything in here. This is your solution set. It goes to the left. So for interval notation, you need two values, a left value and a right value, to separate with a comma. The left value will be negative infinity. If you could keep going all the way to the end of the number line, you would get to negative infinity. So I write negative infinity with a comma, and then I write the negative 3 because that's the right end. So a lot of times students have trouble when there's only one number involved, trying to decide whether it's negative infinity or positive infinity, or even whether the negative goes on the left or the right. You will never have negative infinity as the second number because it'll never be on the right. And you'll never have positive infinity as the first number because it can never be on the left. So in this case, because there's no equal sign, we use round parentheses around both ends. The negative infinity can never be included. Here's example 2. Again, it's only one-sided, so particularly for these, it's very helpful to draw a number line until you get used to this. So this time, x is greater than or equal to 4, so I'm going to fill that in with a closed circle, and x is the bigger one. So this symbol here points to the smaller value. It points to the left, that's the 4. So if 4 is on the left, my x's must be to the right of that. And out here on the other end, the value would be infinity. So I get the left end is 4, the right end is infinity. I put a square bracket for the 4 and a round parenthesis for the infinity, because infinity is not included, but the equal sign shows us the 4 is. All right, and here's a third example. This is between two numbers. So students, if it's written this way with all the inequality symbols pointing to the left number is the left, the right number is the right. Students don't have as much trouble with this usually, but still it could be helpful to draw this number line. Just you have to put both your numbers on, -5, 0. Now the -5 is included. This tells me I'm going to use a square bracket when I do that. The 0 is not included. That tells me I'm going to use a round parenthesis when I get to that end. And some books actually have you put the square bracket on the number line as opposed to filling in the circle and the round parenthesis. That's actually another type of combination notation. So I saw the -5 is on the left and it was included, so there's your square bracket. The 0's on the right. It's always left comma right. What you should see in all of these examples is there are two quantities separated by a comma in between either square brackets or round parentheses. So now is your turn to try some. I'm going to ask you to pause the video, try these, and then start the video to see the solutions. Don't cheat by just watching the video before you attempt, because you really are cheating yourself, because you learn better even if you try incorrectly and then see the correction than you do just by watching me do it. I've done plenty of math. I don't need you to watch me do any more at this point. So try these examples. There are 4 examples to try. So stop the video, do the examples, and come back. All right, you're back. Let's go through these. So this one is -4 less than x less than -2. So I see right away there's going to be no square brackets because there's no equal signs. And on the number line, -4 would be on the left. So I write that first. -2 would be to the right of that. It might be helpful to draw the number line if you didn't see that. And they both have round parentheses. Now, this looks like a point. This looks like x is -4, y is -2. But if you were to see this in the context of a problem, you would have been told on the interval, and then you would see this, so you would know that this means it goes from -4 is less than x is less than -2. Neither of the ends are included. Okay, so that was between 2 points. Now, what about x less than or equal to 10? You may want to draw a number line for this one, and it doesn't need to be fancy, just needs to have the 10 on it. That is filled in, so I know that's going to be a square bracket in one direction or the other. Now x is less than that, which means it's to the left of 10, so my other end is down here at -infinity. So -infinity is never included, so that's a round parenthesis, and it's left comma right will be -infinity comma 10, but the 10 is included, so it's a square bracket. Okay, the third one. Oh, I've got 2 equal signs here. Now, if I were to draw this, most students don't have too much trouble with this one, but you know, if you get them right by drawing it every time, then draw it every time. Don't waste your time working on wrong answers. Here we go. Filled in circle. The 2 is also filled in circle. So what I see is my left end is -5, comma, and my right end is 2, and they both have square brackets next to them because they are both included. And the last practice problem was x greater than -7. So again, especially when there's just one number, graphing this might be helpful. So x is greater than -7. There's an open circle because there's no equal sign. Greater than is to the right. So the inequality symbol will always point to the left value. So -7 is on the left of this interval. And if I go to the right, I know at this end of the number line, it ends in infinity. Doesn't really end, but it keeps going. So I have -7 on the left, comma, infinity on the right. Infinity is never included, and the -7 in this case is not included because there's no equals. Okay, that was all we had for today. I hope this is helpful. You will often find answers given in the back of a textbook in interval notation, and in online software for doing homework will often ask you to give interval notation for answers because it's an easier way to type. You know, if you thought before they had these inequality symbols on keyboards, this was a way you could type an interval without needing a greater than or less than sign. So you will see this throughout your math career, into calculus and beyond, that this is used everywhere. It's like a piece of the language. That's it for this edition of Math Teacher to Go. Have a good day.